This is module number 7, which is the non-parametric tests, and this is part 1. And this is the second to the last of the video lectures that we will be having in this course. So for the part 1, topics included are the chi-square test of independence, and the second one is the Spearman coefficient of correlation. But what are non-parametric tests? So when we speak of non-parametric tests, these are actually the tests that we are going to use if we are going to have a population that is said to be a distribution free, or those populations other than the normally distributed ones. So these are the methods of statistical analysis that do not require a distribution to meet the required assumptions to be analyzed. So again, uh, it is not specified to be normally distributed as regards to the population of interest. So that sometimes these are also referred to as the distribution-free tests, and they serve as an alternative to parametric tests. So the term is alternative, and they are not supposed to be substitutes. So in other words, if in a particular research problem given and there is an appropriate parametric tests to be used, then we use the parametric test rather than their non-parametric counterparts. And these are the reasons why statisticians apply the non-parametric tests. The first one is that the underlying data do not meet the assumption of the population sample. For instance, the assumption of normality. Or the other reason is that the sample size is too small and the required data are in the ordinal or in the nominal scales. So the first one is the chi-square test of independence, so that the symbol used for the chi-square is the Greek letter chi that looks like a letter X. So when we speak of the chi-square distribution, it is also similar to that T distribution because it also belongs to the family of curves, and it is also characterized by a unique number known as the degrees of freedom. And it is emphasized here that the chi-square variable cannot be negative because the distributions are said to be skewed to the right. And of course, the chi-square test of independence is used to test significant relationships between the independent and the dependent variable. So this is the formula. Nasira yata yung ano dito, yung PowerPoint presentation. But anyways, the formula here is clear. So this is the Greek letter chi. So the computed value is equal to the summation of O minus E quantity squared divided by E. O stands for the observed frequencies. These are the actual frequencies in a given distribution. E is the expected frequency. This is the theoretical frequencies. And then this is characterized by the degrees of freedom. C minus 1 times R minus 1. C stands for the number of columns and R stands for the number of rows. And of course, we compute the expected frequency using the formula here. It is equal to the sum of the columns multiplied by the sum of the rows divided by the total sum represented by the capital letter N. Or you may interchange sum of rows times sum of columns because multiplication is commutative. And further, we are going to make use of a chi-square distribution for us to find for the critical or the tabular values of the chi-square. So again, we only have here the 5%, the 1%, and the 0.1% if we're going to make use of this. And this is skewed to the right for skewed distributions. This is our example here. So this has something to do with a new post-operative procedure administered to a number of patients in a large hospital, so that the researcher can ask the question: do the doctors feel differently about this procedure from the nurses, or do they feel basically the same way? So to answer the question, we're going to make use of a test of hypothesis using the chi-square test. So this is an example of the table, and then these are the columns here, and these are the rows, of course. So that in the test of hypothesis, so we are going to look for the given hypothesis, and the given hypothesis will come from the question here. So that our null hypothesis says the doctors feel the same way as the nurses regarding the new procedure, or you may also restate that as there is no significant relationship between the opinions, or uh, the opinions of both the doctors and the nurses. But of course, you cannot easily see it here. That is why we prefer to use the given here. Sometimes, if you're going to formulate the null and alternative hypothesis for the chi-square test, then you may say O is equal to E, or the observed frequency is equal to the expected. So if the doctors feel the same way as that of the nurses, then therefore they are equal. Against the doctors feel differently as the nurses regarding the new procedure, then they are not their opinions are not equal. Pero kung titignan mo kasi dito, hindi mo nakikita na test of relationship siya. Kaya nga ang tawag sa kanya ay independence, test of independence. But in some other texts, they also use test of association. So not unless it is specified na if you are asked to test significant relationship between the two variables. So otherwise, we are going to use the already given hypothesis here. So yan. So for the alpha, it is not given. So again, it is at 0.05. And then we use a chi-square test here because we are talking about the opinions, and we are simply counting the responses. So it is an example of a nominal data. So for the table of values, for the critical value rather, we're going to make use of the degrees of freedom. So there are 3 columns. We have 1, 2, and 3, minus 1. And then there are 2 rows, nurses and doctors. So we have 2 minus 1. That is 2 times 1 is 2. And then this is at 0.05. Column 0.05, row 2. So we go back to the table. This is 0.05, 5%, row 2. And 5% at row 2 is 5.991, understood to be positive. Of course, every given here, these are observed. Totoong nangyari to, binilang nila kung sino yung pabor at kung sino yung hindi. Kung sino yung may pare-parehong opinion or hindi sa lagay na yon, sa tinatanong dito sa hypothesis. So, O ang tawag sa kanila because these were actually observed. So, according to the formula, it is equal to the sum of the quantity O minus E squared. So, wala tayong E. We're going to solve for E, the expected. So, this output is taken from that of the Excel. So, paano gagawin? First, you're going to get the sum of the new procedure, the opinion regarding the new procedure. So, yung 150 is 100 plus 50. This is 80 plus 120. This is 20 plus 30. And then this one is 100 plus 80 plus 20 is 200. And 50 plus 120 plus 30 is equal to 200, and that 200 plus 200 is equal to 400. Ito din, 150. The sum of the columns is also equal to the sum of the rows to get the capital letter N, which is 400. So, for the expected value, output pa rin ito ng Excel. it is equal to the sum of the column times the sum of the row divided by the capital letter N. So, itong 75, ito lang yun, 150 times 200 divided by 400. Eh, since wala namang nabago, 150 pa rin naman, 200 pa rin naman. So, ganun lang, pare-pareho lang. Sum of the column again, 200 times 200, sum of the rows divided by 400. So, we have 100 here. And the same here, 200 lang yon times 200 divided by 400. Yung 25 na to, that is 50 times 200 divided by 400. At itong 25, ganun din, 50 times 200 divided by 400. And then we already have the expected value. Sum of the column times sum of the row divided by the capital letter N. It follows that if you have a bigger number of rows and a bigger number of columns, halimbawa, meron kang 3 by 3 or 5 by 5 or 6 by 6, that means 6 rows, 6 columns. Ganun din karaming E ang isosolve mo. Papantayan mo ng ganun karaming E kung ilan yung O na given. And then we go back to the formula here. O minus E quantity square divided by E. So, kung ano yung subtrahin mo dito, yan din yung nilalagay sa baba. So, kung ilan yung O, ganun din yung kapantay din nun, ang bilang ng E. So, yun lang yung isa-subtract mo. So, dito, 1, 2, 3, 4, 5, 6. So, we have 1, 2, 3, 4, 5, 6. And then, we simplify. So, we get 26.5. Kung hindi kayang dire-diretso sa calculator, pwede namang imano-mano, 6 lang din naman. So, 26.5 is greater than 5.991, and we decide to reject the null hypothesis because the computed is greater than the tabular. And since the null hypothesis is rejected, kinopya lang natin yung alternative hypothesis. So, the conclusion is that the doctors feel differently as the nurses regarding the new procedure. So, kung ang problema nila ay kung tatanggapin yung new procedure, magkaiba yung opinion nila. So, at the end, kung sino yung masusunod, siguro doktor kasi siya ang mag-a-administer nun. Susunod lang naman sa kanyang nurses. That is, if that is the case then. So, that is for the chi-square test of independence, also known as the chi-square test of association. And then, the second one, although this comes last in the module, but this is also a test of relationship, kaya isinama na lang siya sa test of relationship na chi-square din. So, for the Spearman, sometimes this is also known as Spearman law. So, Spearman rank order coefficient of correlation, this is R sub S. Ito yun, R sub S. It is actually the counterpart of the Pearson's product moment coefficient of correlation or R. So, kung ang Pearson's ay R, ang Spearman naman ay R sub S, subscript yung S. So, this is a counterpart, and just like what the Pearson's R tests, the Spearman also tests significant relationship that does not require the stringent assumption of normality. In other words, if it is given in a problem that the distribution is not normal, then you cannot use the Pearson's R. That is the time that you're going to use the alternative, which is the Spearman. And basically, this is used for ordinal data. So the formula looks like this one. It is equal to 1 minus 6 times the sum of D squared. D is simply the difference between the ranks in the independent and the dependent variable. And then n is the number of pairs, and then n squared minus 1. The degrees of freedom is equal to n minus 1. Again, n stands for the number of pairs. So let us have this example. There are two variables of interest here. The independent variable is the number of hours spent studying in the midterm examination, and the y is the grades obtained. Kung sa maigsing pananalita, kapag ba humaba yung oras na nag-aaral ka, tataas din ba ang grades mo sa English? So, is there a significant relationship between the number of hours spent in studying in English and the corresponding grades in the midterm examination? So, nakaspecify naman dito kasi kung wala itong last sentence, baka magamit mo dito Pearson's R. Pero sabi dito, test using a non-parametric test of relationship. So, the counterpart is used and that is the Spearman. So, again, there are two variables. We have the number of hours spent in studying in English and the corresponding grades in the midterm exam. So, pareho lang yung itsura ng hypothesis natin sa Pearson's R. The alpha or the level of significance is not given, so we write 0.05. R sub S, that would be for the Spearman test, Spearman correlation coefficient. And then the tabular value is plus minus 0.618. So, we find that using the degrees of freedom, which is n minus 1. So, n is 12, minus 1 is 11. And then this will be our table of critical values for the Spearman's rank correlation coefficient. So this is two-sided. That is why we used a plus minus. So this is at 0.05 and 11. Ito yun. So 0.05 at alpha, which is at 5%. And then 12 minus 1 is 11. So 11. And so 0.618. So we use the alpha and at the same time the degrees of freedom. So we have here plus minus 0.618 because it is a two-tailed test. Sabi mo lang naman there is a significant relationship. So for the computation of the R, this will be the process. The first thing that you need to do, of course, this is the original given for the X, that is the number of hours spent studying, and this is the Y, which is the grades in midterm exams. So the original given looks like this one. Ito yung original. Ayan, ito yung original. Pero, ang step number 1 is to actually come up with the rank. You have to rank both the X and the Y. So, to do the ranking, so, ito yon, ito, kinopya mo lang to, Excel lang, isosort mo lang from lowest to highest, ganun din yung Y, lowest to highest. So, how do we do the ranking? May mga numbers na dito, since 12 lang naman sila, kapag wala namang magkakaparehong number, ilan lang din naman yung magkakapareho, then yung nakasulat dito na chronological order or chronological arrangement, that will also serve as the rank nila. Ayan. So, halimbawa, itong 5 and 6, tignan nyo, hindi naman siya nagalaw 1 and 2 kasi isa lang naman yung 5, isa lang yung 6. So, ayusin mo muna from lowest to highest. Medyo madali lang naman kasi kakaunti lang sila. And then, magbabago lang naman yung ranking kapag may mga pagkakapareho. So, this is number 10 here, or yung 10 hours na inaral ay rank number 4 at ang isa pang estudyante, 10 hours din na nag-aral. So, rank 4 and rank 5, since pareho sila, hindi naman pwede na number 4 ito at number 5 yan. Kailangan pantay yung ranking nila. Ito yung totoong ranking. So, we do that. We get the average. That is 4 plus 5 divided by 2. Meron tayo ditong 4.5. Eh, paano kung tatlo sila? 4, 5, and 6. Halimbawa, puro 10 yon. So, we get 4 plus 5 plus 6 divided by 3 kasi tatlo na sila. And then, magkakaroon sila ng parehong ranking which is 5. Ganun din yung mangyayari sa rank number 11 and number 12. Parehong 20. So, 11 plus 12 divided by 2, that would be 11.5. And then, we do the ranking for the Y. So, sa Y, madali lang. Mas madali kasi isa lang yung magkakapareho, 85. Dalawang ulit na ginamit. So, we have 8 plus 9 divided by 2 is 8.5. Tapos, ibabalik mo yung ranking dito. Halimbawa, bakit rank 1? Ayan, 5. Anong rank? 1. 6. O, anong rank? 2. Ayan. Eh, bakit 6 dito? Hanapin mo yung number 11. Ayan, number 11. O, 6. O, 11 hours. Lagay mo, 6. 20. Number 20 is here. Tie sila. Dalawa number 20. 11 plus 12 divided by 2 is 11.5. 19. Ilan ang rank ni 19? Ayun, 10. And so on and so forth. Then, as regards to Y, ganun din. 1 and 2 din si 50 and si 60. Walang nagalaw. 1 and 2. Pagdating kay 79, naging number 5. Dahil nandito si 79, number 5 naman talaga. And then, with 90, the rank is 10. Why? Kasi 90 is here, number 10. And then, and so on and so forth. So, yung mga ranking na yan, tignan mo itong 85. 85, 85, 9, 8 plus 9 divided by 2 is 8.5. So, parehong 8.5. Again, kapag pareho yung grades nila, hindi pwedeng magkaiba yung ranking nila. It should be the correct or the accurate ranking na gagamitin natin. Kaya importante yung chronological arrangement dito. D is the difference between what? The rank in X and the rank in Y. So 1 minus 1, 0. 2 minus 2, 0. 6 minus 5, 1. 11.5 minus 10, and so on and so forth. Again, sa Excel ko lang to ginawa. And then, for the D squared, this is D times D. 0 times 0, 0 times 0, 1 times 1, 1.5 times 1.5. Again, 0.5 times 0.5, 0 times 0, 3 times 3, 0.5 times 0.5, and then we get the sum of d squared, that is 17.5. So, ang kailangan lang na value natin dito ay itong 17.5. Ayan. So, doon ang galing ang 17.5. Ang 6 ay constant, ang 1 ay constant. So, we compute and we obtain 0.0939. Tinatlo ko na lang kasi tatlo din naman yung nasa tabular value. Since 0.939 is greater than 0.618 positive, then we reject the null hypothesis and we conclude that there is a significant relationship between the number of hours spent in studying in English and the corresponding grades in the midterm examination. So, what does it imply? Mag-aral ng medyo mahaba ngayong final exams para tumaas ang magiging result. Because the number of hours spent in studying is correlated to the grades that you are going to obtain. So, thank you very much, and